Hi, can everyone hear me? Thank you. So I posted the question on Google Drive as usual. Please check on Corpus, the link to the Google Drive. Today is tutorial 3. Okay, so let's start the tutorial today. Today we will talk about events with equal probability. We talked about definition of probability in the last tutorial, so I don't think I will have to repeat that. We will also talk about multiplicative law. So the first one is for equiprobable events. It just means, let's say your sample space have a bunch of events, W1, W2, up to Wn. And let's say that your sample space is finite. And this word, it means that every event in your sample space have the same chance to happen, which means probability of W1 equal probability of W2 equal probability of Wn and equal to 1 over n. And let's say you have A is some event, which means A is the subset of the sample space. So this is some event. It might be event containing one outcome. Like let's say you can have A equal to W1 only, that's possible, but A also might be a composite event, which means it can have more than one outcome, like W1, W2, something like this. Then the probability of A is equal to number of elements in A divided by number of elements in the sample space. Does this part make sense? In other words, it's just cardinality of A divided by cardinality of the sample space. So that is the first thing for equiprobable event. The next one we want to talk about is multiplicative law. Let's say that you want to calculate the number of ways to perform something. Let's say I want to reach from my home. Here's my home. And I want to reach to UTM. But in the middle, I have to buy bubble tea. Okay. I'm not really good at drawing, so I hope you can imagine. So there are two ways for me to get from my house to the bubble tea store. And then there are 3 ways from the bubble tea store to UTM. So how many number of ways I can get from my house to UTM such that I pass through the bubble tea store? It would be like, so this is the first way I can get from my house to the bubble tea store. And then once I get there, once I get here, I want to go to UTM, right? And there would be 3 ways for me. Like I can go this way, or I can go this way, or I can go this way. Which means that for each of the way I go to the bubble tea store, there are 3 corresponding way I can go to UTM. Yes, I see a student answer. So the answer is I would have 2 times 3 equal to 6 ways from my house to UTM. And make sure that we use this multiplicative law, because for each of the step in the first step, for each of the way in the first step, there are 3 corresponding way in the second step. You cannot apply multiplicative law if you have something like, let's see. So if I erase this, and I erase this. If I say that, okay, if I take the first way here, then I have to use the second way to get to UTM. If I use the third way here, then I can use either the fourth or the fifth one to get to UTM. Like if somehow I choose to go by this way in the first step, then I have to use the second way in the second step. Or if I use the third way in the first step, then I have to use the fourth or the fifth way in the second step. If there is such restriction, then you cannot use multiplicative law. You can only use multiplicative law if we have something like in the beginning, where each of the way in the first step, you have the same amount number of way in the second step. So please keep that in mind. So in general, what we can say is that the number of way to perform an event, you should think about like, okay, I can do that. I can perform such action by having step 1 is do something, step 2 is do something, and then step K is do something. And then you calculate how many ways are there. You can do step 1. Let's say you have N1 ways to do step 1. And for each of the way in step 1, you have N2 ways to perform step 2. And similarly, for each of the way in step 1 up to step K minus 1, you have NK ways to perform step K. Then the number of ways to perform such action consists of K steps, would be N1 times N2 up to NK. Does this make sense? Okay, thank you. So if there is no question, I will let you do question 1. You can put in the chat if you have any question. I do see the student ask something like K factorial. The thing is, when you have K factorial, it means like, okay, my first step, there are K ways to perform it. My second step, there are K minus 1 way. And up to like the last step, I would have only 1 ways. So something like that would give you K factorial. So normally for the question that throwing two die, what I normally do is drawing a table like this, where this row represents the outcome of the first dice, and this row represents the outcome of the second dice, or you can switch the order, that doesn't really matter, as long as you are consistent. And in the intersection of each row and column, since here we are interested in the sum of the two outcomes, so I will write down the sum. For example, like if the first die I get 1, and the second die, in the second row I get 1, then the sum of the two outcome is 2. Similarly, I fill in like 2 plus 1, 3 plus 1, give me 4, 6 plus 1, give me 7, something like that. So this is how I construct my table. For the first question, they ask us to write out the simple specs. So remember, when they ask you to write out the simple specs, you have to clarify it is a set. Make sure that it is a set. Don't just draw this table. This table is like a visualize, it happens to visualize what's going on, but it is not like proper notation. And what you have to do is you have to list out like 1, 1, 1, 2, up until like 1, 6. And then 2, 1, up to 2, 6. 3, 1, 3, 2, up to 3, 6. Something like that. You have to list out everything on the midterm or in the final exam, okay? The second one, I saw some students put in the answer. They put first one is 6 over 36 and B is 5 over 36. So let's see. So let event A be the events where at least one outcome is 4. We know that the events are equiprobable, which means that here the simple specs have 36 elements in total. So each of the outcome, for example, like the outcome 1, 1 or the outcome 2, 1, everything, they have same chance of happen, which is 1 over 36. So here, if I want to know what is the probability that I have at least one outcome is 4, I have to take cardinality of A, which is the number of elements in A, divided by cardinality of the simple space. So in the midterm, what we expect you to do is you have to write out what is A. What does A contain? Don't just write the final answer, because even though I see that you are giving the correct answer, I think that you know what is going on, but you didn't really show us like your whole process, so you might not get a full mark. So in the midterm or in the exam, please like define the event, because if you don't define, we don't know what is A, right? So first define an event. A is the event where at least one outcome is 4, and then you list out what are the elements of A, and then finally you will use this formula, probability of A equal to cardinality of A divided by cardinality of the simple space. So we want at least of the outcome is 4, which means I'm looking at this. Oops. Okay. So everything in this column would have at least this outcome is 4. And then everything in this row here also have at least one of the outcome is 4, right? So what you have to do is you have to write down something like 4, 1, corresponding to 4 and 1. And then you have to do this one correspond to 4 and 2. And then up to 4 and 6. And then you will write down the row here, which is 1 and 4. Up to 6 and 4. In the exam, we do expect you to write out everything, not just dot, dot, dot like I did. I did it here just because for the sake of time. And you will see, okay, how many elements are there in A? Here I have 6, right? Here I have 6, but then they overlap this one, which means I have to minus 1. So I would have 11 over 36. Okay. Yes, I did see the student answer change, not 6 over 36, but 11 over 36. And that was correct. Any question about this part? So this is part A. Please stop me if you have any question. Next time, I define event B, which is an event where sum of the two outcome equal to 6. And I also have to list out what is in B. And then I also do this probability of B equal to cardinality of B divided by cardinality of the sample space. So here I want those that have the sum equal to 6. And how do I look at the sum? The sum is all the number in the intersection here. Like it is here, right? And I want the sum is 6, which means I want this part. I don't know if you can see it. Okay, so this part is all the outcome such that the sum is equal to 6. So I will list it out. First, this one corresponds to 1 and 5. And then I have this one, which is 2 and 4. Then I have 3 and 3, 4 and 2, 5 and 1. Okay. And then I have cardinality of B is the number of elements in B. B have 1, 2, 3, 4, 5, 5 elements. And simple specs have 36 elements. So this would be the final answer. Any question about this one? Does everything make sense here? Okay, if no question, then I will let you work on question 2. Please leave a message if there are anything you are confused about. What app am I using to write? I'm writing on GoodNotes. I think it is free on iPad now. This one, I don't remember if it has S or not. When I got it, I had to pay like $4 or $5, but I think now it is free. Since every digit have the same probability of being selected at each step that you choose, so it is something to do with equiprobable event. So you should think about the formula where you have like probability of A equal to cardinality of A divided by cardinality of the simple space. So you should use this formula. It is pretty straightforward. Okay, let's look at this. These a bit generalized when you are talking about AN. So I think we should start with something specific for you so that it is easier to understand. For example, A1 means that the first decimal digit is 1. So if we think about it, what is the probability that the first decimal digit is 1? So it is when A1 equal to like 0.1, right? Because here we are just restricting our focus on the first decimal digit. So A1 would be like something like 0.1. Actually, let me think. I don't think it is a good way to denote for this. Like 0.1, let's say something like behind it, there might be other digits as well, but we don't really care. So we will have cardinality of A1 divided by cardinality of the simple space. And what is our simple space? Our simple space would consist of number like 0.1 and something behind it, and then 0.2 something behind it, up to 0.9 and something behind it, right? So if you look at this, you will see that the cardinality of A1 is 1, and the cardinality of the simple space here is 10. So for probability of A1, I would have it is equal to 1 over 10, which is 1 over 10 to the power of 1. And you can do the same thing for A2, where the first two decimal digits is is 1, which means A2 would consist of the number like 0.11 and something behind it that we do not know and we don't really care. In the simple space, you will have like 0.11 something, 0.12 something, up to like 0.19 something, and then 0.21 something, up to 0.29 something. And in the end, it will be like 0.99 something. So you will see that when you choose the 2 digits, how many ways are there to choose the first digit? I missed something here. So like you have to choose 2 digits. Each of them can be any from 0 to 9. Which means for the first digit, you have 10 choices. For the second digit, since there is no restriction, there are also 10 choices. Which means that the simple specs here would have 10 to the power of 2 outcomes. Because it boiled down to how many ways, like how many 2 digits that you can form, 2 digits number that you can form, such that each digit can be from 0 to 9. Then you will have probability of A2 is cardinality of A2 over cardinality of the simple space. And A2 only have the number like this. So you have 1 divided 10 to the power of 2. And then you can generalize it because the simple space, when you choose n digit, which means like you would have n digits in total. For each of the digits, it can be anything from 0 to 9. Which means for each of the digit, you have 10 choices times 10 choices times 10 choices, and you have n digits in total. So you would just have 10 to the power of n. So this is the situation when you care about n digits. Then probability of an would have to be something like 0.1111 and then something behind that. And here you would have like n times 1. So probability of an would just be 1 divided by cardinality of the simple space, which is 10 to the power of n. So this is how you reason about that.
I have a question.
Yes.
I didn't like a different way. I just said, like, I skipped to the end, right? And I just said for any digit we have n digits, right? Then
Yeah.
instead of like doing A1, A2, I just said a general A and said that the chance for some digit has to be between 0 and 9. It's got that to be 1 over 10. I said, okay, we have that n times, and then we multiply all of them, and then we get 1 over 10.
Yeah. That's also fine.
Okay.
Yeah. Any other questions? Okay, if not, then I will let you work on question 3. I think it's pretty straightforward as well. So for the question 2, the next part of it would be proving that the sequence an for n is at least 1. Prove that this is like decreasing sequence. So I think you should think about that. I will cover it in like tutorial 0102 if you want to know the solution, but I really encourage you to give it a thought. It's not that difficult. For your interest, there are 26 letters in English alphabet, and then there are 10 digits, like 10 number. From 0 to 9. Did anyone get the answer for part 1?
Would we have 3 letter choices at the start? And the rest would just be the same, like 26 and 10.
26? And then 26? How about the last 4? I do see some student answer 3 times 26 times 26 times 10 times 10. It looks correct to me. So what the student did was that, okay, you have a registration plate and you have 3 letters and then you have 4 digits. Then you will choose, okay, how many choices are there for the first position? My plate have to start with A, E, or I. So there are only 3 possibilities for the first position. How many choices are there for the second position? It can be any letter, and there are 26 letters in total. So I put times 26. And how many choices are there for the third one? Since it can be any letter, it is 26 choices again. And each of the plates here, it can be any number from 0 to 9. So there are 10 choices for each of them. So I think that's how the students got to their answer. How about 2? You want it to end with 4 or 5 and no other restriction. That one look almost correct. Yeah, you forgot a 10. So here you will see how many choice are there for the first one. You have 26 because it can be any number, right? Similarly, for each of these, so I have 26 together 3 times. And then each of the digit here can be any number from 0 to 9. So it is 10 choices for each of them. And the last digit has to be 4 or 5. So there are 2 choices. So I just times 2. We need to divide by S. Oh, yeah, you're right. I missed that. I missed the probability. You're right. So every answer that I wrote here, I have to divide by the cardinality of the simple space. And what is that? What is cardinality of the simple space? Yeah, that was correct. It is 26 to the power of 3 and 10 to the power of 4 because there is no restriction, right? So each of the green spot can be any letter. Each of the red spot can be any number. I have this here as well. How about the last one? I want it to start with A, E, or I and ends with 4 or 5. What should be the numerator? So again, if we think, yeah, that looks right. So the student choose how many choices are there for the first one. You have 3 because it has to be A, E, or I, right? The next 2 letter can be anything. So it is 26 choices. And then the next 3 digits can be anything. So it is 10 to the power of 3. And the last one, you have to end with 4 or 5. So you only have 2 choices. So this would be the correct answer. Does this make sense for everyone? Okay, if there is no question, I will let you work on question 4, maybe 5 minutes.
For the question, where it says omega equals, wouldn't that be XYZ instead of XYX, or is it supposed to be like XYX?
This one
No, beside it.
is, oh yeah, it should be XYZ. Did anyone got the answer for part 1?
Would it be k cubed?
Yep, that sounds right. So because you have to count, I think about you have 3 spots and you want to fill them in. How many different numbers can you get if each of the spot can be any number from 1 up to k? So the first spot can be any number from 1 up to k, so there are k choices. Similarly, for the second spot, also k choices, also similar to the last one. So I have k to the power of 3 elements in total in the simple space. Stop me if you have any question. The next one, I want to verify that AI are pairwise destroyed, and then the union is just A. So let's say we want to look at AI intersect with AJ. For I is different from J. We will show that for every pair of AI, AJ, they are pairwise destroyed. No matter it is like A1, A2, or A2, A3, or A1, A3. So we show this in general because we do not pick specific value for I and J. We just talk about it in general. Like assume that I and J are different number, and we will look at the intersection of 2 sets, AI and AJ. And if we can show that their intersection is an empty set, then it means 2 sets are destroyed, right? So here I will write down AI consists of I, Y, and Z such that Y and Z is smaller than I. And then intersect with J, Y, and Z such that Y and Z is smaller than J. Do you think there are any common elements between these 2 sets?
No, since I and j are different, the tuples
Yeah,
can't be the same.
exactly. So this should result in an empty set because I is different from J, which means that all the tuple I, Y, and Z is different from the tuple J, Y, and Z for every Y and Z. So that is how we show that the 2 sets are destroyed. And since we talk about I and J generally, so we show it generally. Let's see. Next one, we want to show that their union give us the set A. So I will write down A. A is X, Y, and Z, where Y is smaller than X and Z is smaller than X. So if you recall the concept of partition that we talked about in last tutorial, how can we partition this set based on the value of X? What are the possible values that X can take on? Can X be equal to 1?
2 to k?
Yeah, it has to be 2 to k, right? Because think about it. If X is 1, so Y has to be less than 1, Z has to be less than 1. However, like in our simple space, X, Y, Z, the minimum value is 1. Therefore, if X is equal to 1, then there is no Y and Z that satisfy the condition. So X has to be at least 2. So I will write X equal to 2 here, where Y and Z is less than 2. Union with when X is equal to 3, Y and Z is less than 3. Similarly, union with like when x equal to 4, equal to 5, equal to 6, and up to x is equal to 9. Sorry, not 9, equal to k. Because it is the maximum value x can take on. You also have y and z is less than k. So if we look at each set here, this set, what does it represent? You have a tuple of 2 y and z, such that y and z is less than 2. So what is this set?
(211).
Sorry?
Would it be 211?
211. Why do you think so? I mean, like, if it is correct, it is correct that this set would be the set consists of the tuple 211, but I want something more general. This set has a name that is defined in the question, right? Yes, exactly. It is A2. Because if you match it with this definition, AI consists of tuples start with I, and Y and Z is smaller than I. So here it consists of tuples starting with 2 and Y and Z is smaller than 2. And then the next set would be A3. And the last set would be AK, right? And this one you can write in the notation AI such that I range from 2 up to K. Does this make sense? Any question about this part? If there is no question, then I will stop the tutorial today here. There is only this part 3 left. I don't think it is too difficult, so you can attempt by yourself. If you are not confident, like there's anything you doubt about your answer, you can always post on Piazza. A2. Yes, like A sub 2. Like this kind of notation. So for part 3, what I can tell you is again equiprobable event. So you want to find probability of AI, think about what is the cardinality of AI and then divide it by cardinality of the simple space. Similar for this one. And this one here, you should have probability of A is equal to summation for probability of AI. Why is that? Because these AI partition the set A, like A1, A2, A1, AK partition the set A, because their union is A and their pairwise destroyed. So you will need to use this formula to calculate probability of A. If there is no question, then it's the end of our tutorial.